This conference will now be recorded.
Hey guys, this is Naveen here. Welcome back to Naveen Automation Labs. So guys, with this particular video, I'm going to start a Docker series, which is like these days quite important and quite famous to know. And a lot of people were asking about to start this particular series on my channel. So today we will talk about what do you mean by Docker, the basic introduction about Docker, and then in upcoming videos, I'll tell you what are the different things we can do with Docker, what is Docker Hub, what is Docker image, what are different Docker containers, Docker, how to install the containers on your system and all those things. So a lot of things we will do. But today, first we need to understand what is Docker, why exactly it came into the picture, and then what is the benefit, what kind of application we can use with respect to Docker, and right. So let's start. Okay, so the topic is what is Docker? So guys, Docker is nothing, it's just a technology, it's just a software which will help you, or which will help your dev team or testing team to build the application, to manage the application, and to secure application anywhere on any platform. So earlier, if you know that the typical example of virtual machine, or the cloud and hypervisor, or maybe hardware, earlier how exactly we need to deploy, how exactly we need to deploy the system, how exactly we need to deploy our environment or applications. So what we need to do that, okay, earlier we were having one hardware before Docker. So let's see, this is my hardware. On this particular hardware, I install one operating system, let's see Linux OS, right? This is my Linux operating system. And on this particular Linux OS, earlier, what exactly I need to install? I need to install one software that is called hypervisor, right? I simply say, let's see, hypervisor, which is provided by maybe AWS, or maybe Dell EMC Square, or maybe or maybe Cisco or whatever. On this particular hypervisor, let's see, I want to install multiple applications. Let's say I want to install my Tomcat, I want to install my DB servers, I want to install my Cassandra, MongoDB, or Jenkins, or maybe some other application. So what exactly we have to do that, guys? We have to create multiple VMs. So let's say VM number 1, VM number 2, VM number 3, like this. So multiple VMs we have to create on these systems, I mean on this particular hypervisor, and every VM will have its own operating system. So let's see, I want to install Linux machine, I want to install, let's see, a MySQL server on Windows machine, so I need one Windows server. Other than that, let's see, I want to install some other operating system, something like this. For my Jenkins, I want to install some other, let's see, SQL server. I want to install, let's see, my Tomcat on this particular operating system, and I want to install some other thing, some other application on this particular operating system. So these are different VMs, guys. So this is, let's see, VM number 1, VM number 2, like this. I quickly write, let's see, something like this. So these are the different VMs are available. On these VMs, we will deploy our application. So how exactly you will deploy? So we will, let's see, host our services, host our applications. Let's see, my application number 1 is Jenkins machine. I want to install Jenkins. So Jenkins is running on this particular system. I want to have, let's see, my Tomcat. Tomcat is available on this particular system. I want to have, let's see, some SQL Server, right? Microsoft SQL Server is available on this particular virtual machine, or maybe some other mobile application is running on this particular thing, or maybe some backend services, okay, also running on this particular virtual machine. And these virtual machines, they are communicating with each other on the same hypervisor, on the same Linux kernel operating system, on some different hardware. So now you think about this. First of all, on the same Linux OS, either you can create multiple VMs, so you have to procure, you have to put some efforts and infrastructure point of view, and you have to pay extra money for it, for these VMs, right? So these operating VMs we have to create, or you can buy some different 5 or 10 different machines. They are communicating with each other, and then Jenkins is deployed on some other server. Tomcat is deployed on some other servers. SQL Server is deployed on some other server on some different machine. So if you see this overall architecture, this overall design, it's quite expensive, right? We have to procure so many hardwares, we have to procure so many VMs, and we have to pay for it, for their services, for their whatever the compliances these guys are providing, we have to pay for it. Now, after 2013, Docker came into the picture. So they started working upon Docker, okay, in 2010, but 2013 was the first release, okay, happened in the market. And then what exactly Docker says? Docker's guys says that okay, this is the same hardware. Let's see, this is my hardware, right? On this particular hardware, I have my Linux operating system. Let's see, whatever the Linux or Windows machine or whatever Linux OS. And on this particular Linux OS, what I'll do that I'll install. No need to install your hypervisor. You just install one Docker engine over here. So this is my Docker engine is running on this particular machine. So let's see, this is my Docker. Okay. So Docker engine, I would say. Let's see, this is my Docker engine is running. So Docker is nothing, just a software we will install on this particular operating system. And then what exactly we will do that on this particular through Docker engine on this particular hardware, we don't need any hypervisor, we don't need any VM. On the same hardware, guys, we can create multiple containers. Let's see, this is container number 1, container number 2, this is container number 3, container number 4, and container number 5. What do you mean by container? Container is a kind of Docker image, a software image which will hold all the information about that particular software. Let's say I want to install MySQL Server. So to install MySQL Server, what do you need? So let's say I want to install MS SQL Server. For this, I need all the libraries. I need all the binaries, right? I need what on which port number you want to install, what will be the IP address it will take. So all these information, the binding information, porting information, libraries, any extra configuration if you want. So I'll put everything inside the image and I install this particular image on this particular container like this. And now this container will behave like a separate VM, or I would say a separate entity, just like a separate service container service is running on this particular Linux machine. Same thing I can do it. Let's see, I want to do it for Jenkins. Same thing, I'll do it for Jenkins. So this is my Jenkins container. Let's see, I want to install some other thing. Let's see, my Tomcat. So this is my Tomcat installer, right? I want to do, let's see, for Oracle, I want to install Oracle. So this is my Oracle container is running on this particular container, right? I want to install, let's see, some mobile application or something like this. So let's see, some mobile application also running on this particular container. So all these applications, see, we have different applications. So application doesn't mean that, okay, google.com. I'm not talking about google.com. I'm talking about what are the different components, what are the different designing components that you are using in your system. So we have SQL Server for database, Jenkins for CI/CD, Tomcat for app server, Oracle for database server, mobile application we are using, let's see, for some mobile servers we are using for that. So we are running on these machines as a separate container on the same hardware. So first of all, we don't need any hypervisor. So we don't need to spend money on hypervisor. We don't need to create so many virtual machines. No, not needed. On the same this Linux OS, okay, we don't need to get extra hardware also, right? But in the previous approach earlier, first of all, we need to get this hypervisor. Then only we can divide this, but then only we can provide the virtualization with the help of this particular hypervisor. And this hypervisor will create multiple VMs on this particular system, or maybe we can associate multiple hardware also. Let's say I'll get one more hardware, two more hardware, and three hardwares I'll create, and then these hardwares are connected with each other. So ultimately the cost is very much, right guys? And this is the biggest problem, guys, with this particular approach. Docker container says that, okay, no, you don't need to do anything. We will take care of everything in terms of installation, in terms of configuration, in terms of application is up and running. And it is so easy to configure. It is so easy to maintain and handle very fast. So that's why Docker came into the picture, guys. That's why it got very popular. Now, what is the biggest advantage? Advantage is this isolation of the container. These containers are totally isolated. MySQL Server and Jenkins, these two containers are totally isolated. Jenkins and Tomcat, these are totally isolated. They are not sharing any resources. Resources means RAM. Resources means their memory, their size, their communication between these two containers are not happening, right? So these two containers or multiple containers are independently working, okay, available on the specific Linux machine or hardware. And then these containerized processes can run side by side on the same computer. It's running on the same computer. We don't need to have multiple computers or multiple hardwares for that. And they cannot interfere with each other. It's separately running somewhere, it's separately running somewhere with, okay, like this. And sharing the common resources and the services from your operating system. But here we have to define multiple operating systems. We have to create multiple VMs like this, right? Okay. Other than that, they cannot share the data with each other. They cannot share that, okay, Jenkins is passing some data to MySQL server and MySQL server is passing some data to Oracle. Explicitly, through some configuration, we can do that. But those are totally independent, totally isolated, totally secured. So security is the biggest thing over here, and isolation is also the biggest thing over here in these containers. Shared hardware means, what do you mean by they are sharing the common hardware? Shared hardware means that, see, earlier we used to have multiple hardwares, let's say 10 hardwares or 20 hardwares we have to procure, and then let's say Amazon or Flipkart or Walmart. Okay, Walmart. Okay, these companies, they have to procure so many hardwares for that. Okay, so that they can install multiple applications on those hardwares, and then they can communicate with each other like this. So here, we don't need to do anything. We just need to have a massive hardware, and that's it. And then completely, you guys can install multiple containers available on the same machine. So the maintenance point of view, it is quite easy, less hardware, okay, concept we are using over here. So this is the biggest advantage with a Docker container isolation base. Then what we need to do now? So for further thing, guys, what we need to do, just a second. Yeah. Now, I'll give you one more example. Let's see how exactly the memory sharing point of view or memory management point of view, how exactly Docker containers and the earlier things that we were using that, let's say I'll give you an example over here. In this particular approach, my machine is around, let's see, 16 GB machine. Okay, 16 GB RAM I'm using. 16 GB RAM is used by Jenkins. So let's see, Jenkins is using around, Jenkins is using around 6 GB I have allocated for Jenkins. So I'll write something like this. Let's see, Jenkins. I have given, let's see, 6 GB, okay, RAM for this particular guy. Out of 6 GB, it's using only 4 GB, right? So what is the pending GB is there? 2 GB, right? So 2 GB is totally wasted for Jenkins for VM number 1. Let's see, for this particular VM number 1, right? Okay, fine. Same thing, let's see, for Tomcat, that is running on VM number 2, okay, and I'm giving, let's see, around 4 GB for Tomcat. Out of 4 GB, it's taking only, let's see, 2 GB, and which is equal to 2 GB unnecessary we are allocating. So that's again for Tomcat VM number 2, we are wasting 2 GB, right? Like this. So 6 plus 4, 10, and let's see, 16 GB machine is there, 6 GB for SQL Server. So I'm writing the same thing, 6 GB for SQL Server I have given. Out of 6 GB allocated to allocate memory for SQL Server 6 GB, but SQL Server is taking only, let's see, 3 GB, right? So unnecessary we are wasting our 3 GB over here as well, or GB or RAM or whatever. Let's say I'm talking about the size, the total disk size. So what is the total waste memory, the total waste size we have, okay, over here? So waste is 2 plus 2, 4 plus 3, 7. 7 GB is the wasted RAM or wasted memory. And you have allocated, but this particular VM, you have allocated, let's see, 6 GB, but this particular VM is using only 4 GB. That's it. So what will you do with 2 GB? You cannot give this particular 2 GB to some other VM. No. Right, guys? You cannot give. Because these VM, they cannot share the resources. Right? This VM is separate, this VM is separate. They cannot allocate this, okay, the extra memory which is available for VM number 1, it cannot be allocated to VM number 2. Now, if you see the same concept over here, same concept here, let's see, you have given 16 GB total memory is there, right? And you have given allotted, let's see, in case of Docker, you have given for this guy, let's see, you have given 4 GB, and out of 4 GB, you are using, let's see, 2 GB, and 2 GB you have saved for this particular guy, right? And let's see, for another guy, you have given 6 GB, and you are using only 4, which is okay. Now you are using extra spaces, 2 GB for this guy. So what we can do, that guys, this 2 plus 2, 4 GB is still is your Linux common operating system memory, which can be assigned to Tomcat, which can be given to Tomcat or Oracle or mobile application or maybe some other service, which is not possible over here. So this is the biggest advantage, guys, that okay, while using the Docker container images like this, right? So this is how we have to uh, okay, this is how we can save the cost, this is how we can save the resources, memory allocation, and the configuration and the maintenance also very easy with respect to Docker. Now, why Docker is popular? How exactly Docker is popular? So if you see the Docker trend on Google, I'll show you. So you simply open Google Trends. Okay, just open Google Trends and you simply write search a term over here, Docker, and then let's see Docker as a software. And from last let's see 5 years trend, you see amazingly good. This is a trend. In 2014, it was recently released around 2013 or something, and then you see the graph of Docker. Now this is so popular, most of the companies, they are using Docker these days like this. So this is a actual graph for actual trending graph for Docker. Not even United States. Let's see, I'll go about worldwide. If you go with worldwide for 5 years, see the graph, guys. Amazingly good. Almost all the companies, okay, almost all the countries, they are using this particular Docker container concept over there for deploying, for building, and for security point of view, for hosting point of view, they are using Docker containers for this. Right? So what is the biggest advantage? Why Docker is so popular? So if you see, I have already given you some basic points, but the first thing is, guys, it's so easy to use. That's why it's so popular. Second, for the large scale, okay, for the large scaling or faster scaling, I want to deploy quickly. Daily basis, I have so many deployments. Okay, in that case, Docker is the best choice for this, right? Better software delivery, or let's say your velocity of deployment is happening quite frequently, right? A lot of changes you are doing on production daily basis or weekly basis. So again, the velocity of deployment is high. So in that case, quite good. Easy to maintain, easy to use, flexible. Okay, it's quite flexible, right? Like this. And then especially for microservices architecture, guys, it is being used for Docker is being used for microservice architectures. These are the, if you satisfy with all these 5 rules, it means Docker is the first choice for that. Now, how exactly it can be used for microservices architecture? So let's see, I'll give you an example, a real-time example. Let's see, Amazon.com or Flipkart or Uber or whatever, they are using, let's see, one hardware. On this particular hardware, what exactly they do, there are so many services are available, right? These are the different microservices are available, and each and every service is doing something. Okay, each and every service is doing their own work, having it responsible for their own configuration and own they provide some data to the user. It's having their own work. And these services, let's see, for the first service, I'm using some, okay, let's see, for Microsoft MS SQL, or some backend service is running for Microsoft SQL, some running, something is running for your backend services, okay, something is running for some other services like this. So let's see, service number 1, service number 2, service number 3, like this. There are so many services are running over here. These are the small microservices are there. And these microservices are loosely coupled with each other. It means these are isolated. So what exactly we will do that, guys? For each and microservices, we will host these microservices with the help of Docker container, right? Each and every service is having its own container like this. This is okay. Different containers are available over here like this, right? So with the help of Docker, so we will install one Docker engine over here. Okay, this is my Docker engine. Okay, this is my Docker engine which is running on this particular system, and through this Docker engine I can easily do a lot of things. What exactly I can do? Easily deploy my services, easily maintain, I can add the services, I can update the services, I can delete my services. Okay, easily I can do all these things. I can quickly I can deploy my services like this on production environment like this. So all these operations easily you can do with the help of Docker containers, guys. Right? And these containers are not talking to each other. They are totally isolated, totally secured. There is no involvement of one container to another container. So that's why it's very powerful for microservices architecture over here. Right? Okay. So if all these things, okay, you're looking for these 5 important points, if you're looking for, it means Docker is the best choice for you guys. But the last concept is that why you should not use Docker or containers, in which case you should not use. If you, let's see, already having one system, which is already quite old system, which is already using this particular concept, and you don't want to disturb your architecture or a deployment strategy or something like this, in that case, you don't need to touch. Second thing is that you need some extra talent for this. You need to hire those people who can actually they know Docker, they know container virtualization, they know Docker container, they know how to create the images, a good DevOps team, a good SRE team. Then only you should adopt Docker. It's not like that. Okay, it's not everyone's development responsibility. No, it's not like that. Okay, like this. So that's why, guys, Docker is quite popular. Now, the last point I would like to cover that how exactly Docker can be used for testers, automation engineers. Of course, it can be used for testers and automation engineers. Let's see in terms of Selenium. What exactly we do Selenium in Selenium Grid? In Selenium Grid, earlier what we used to do that, okay, we have one Selenium hub. And Selenium is connected to multiple nodes over here. Node number 1, node number 2, 3, 4, 5. Let's see, one node is for Firefox, one node is for Safari, Internet Explorer, Opera, or maybe Google Chrome. And all these, what I need to have 3 plus 2, 5 plus 1, 6 different machines I need to have, or maybe 5 different VMs I need to have, having different operating systems. Right, guys? So that was a very tedious, complex infrastructure and the configuration and the cost point of view also I have to do it. Or either I have to go to let's see browser stack or maybe source labs or something, and these guys also having multiple VMs which are available on their system, and then you have to pay for each and every VM for that. But with Docker you don't need to do all these things. What you need to do, let's see, this is my machine. On this particular machine I simple install my Docker engine. Let's see, de is my Docker engine. And through this particular de, what exactly I'll do, guys, I simple install one Docker hub container, one container for hub, right? So let's see, this is my hub container, Selenium Grid hub. And this particular, after that, I will install multiple containers for Firefox. One is for Google Chrome, one is for Internet Explorer, one is for Safari, like this. So on the same hardware, on the same machine, what I'll do, I'll define different containers for different browsers. Let's see, one is for Firefox, one is for Google Chrome, one is for Google, something like this, right? For different browsers. One is for Internet Explorer like this, and one is for, let's say, Safari, right? Let's for this is for Safari. And this particular through Docker, I configure, okay, like this. My hub is connected to multiple nodes over here, Internet Explorer and the Safari, like this, right? So all these things you guys can easily do with single command. With one or two commands, guys, easily you can do that. And whenever you want to start the hub, whenever you want to stop the server, when you want to disconnect this particular node, easily you can do it. But here the maintenance also very, okay, very costly. Here the thing is that you have to start your Selenium Grid. If Selenium Grid is got stopped somewhere, again you have to restart. Again you have to connect with the multiple nodes. So a lot of configuration and unnecessary. You have to waste your time in this particular configuration, right? But here with the same Docker container, let's see, it's running on my some Linux machine on AWS, that is Amazon Web Services. I have procured one Linux operating system. On that particular operating system, I have installed my Docker engine like this. And then here locally, I'm writing my Eclipse code, right? And I just whatever the hub server that you are using, the same hub server and port number I'll be using in my script in the form of desired capabilities or something like this. And then I'll trigger and my test cases on hub, and hub will distribute my test cases on different nodes available in the form of different containers. And these nodes are not talking to each other. So there are no conflicts, totally isolated. So in Selenium Grid also easily we can do that. We don't need to have multiple VMs or multiple hardwares, guys. So this is the biggest advantage with Docker in test automation also. Okay, so I'll be preparing one video later on these things. So just today, guys, it's only for introduction about Docker, how exactly Docker works, how exactly why it is so popular, what is the purpose of Docker, Docker container, and all those things, right? Like this. One more thing, as I told you, each and every Docker container image is available on dockerhub.com. So we need to go to hub.docker.com. We can easily pull the image. So in the next video, I'll show you how to get the image and how to install it. And there are certain commands are available. You just need to install Docker on your system. That's it. That particular image container on your system. That's it. And automatically, you don't need to do anything. Automatically, it will install all the respective libraries, all the respective binaries, your configuration, your environment variables, everything will be taken care by Docker. Here you have to do everything by your own. Okay guys, so you just need to get the right image, right container image, and install it on respective operating system. That's it. So this is the power of Docker, guys. Okay, in the next video, I'll tell you how to create Docker Hub account, how to install Docker on Windows machine and the Mac machine and other popular images also. Let's see, we can have one example for how to install SQL Server. If you install SQL Server by your own without Docker, it is so difficult to do that, guys. It's not that easy. The configuration is quite complex, right? But if you are installing SQL Server with Docker container images, easily you can do that. In fact, Jenkins also you can do with Docker. You don't need to install Jenkins separately. You just need to install Jenkins container image on your system. That's it. One single command will do everything for Jenkins. Okay, so those examples we will see in upcoming videos. So that's all for today, guys. If you really like this video, please subscribe to the channel, like the video, and share with your friends and colleagues, and let me know if you have any questions about that. Thank you so much, guys.